So here we go with the joins and relates lecture, which we'll be watching here before we do the joins and relates demo interacting with the software. So in this case, we're attaching additional data to our GIS data attributes. And again, this module is all dedicated to interacting with our GIS data's attributes. So what do we mean by attaching additional data to our attributes? Well, we could have disparate databases, disparate tables, maybe a shapefile that has some fields in it, and we have need to put additional fields into it that exists in another place. So that's what we mean by a disparate table that we would maybe want to join to our GIS data. So remember, there's two different types of attribute tables. Of course, the ones that are associated with our points, lines, and polygons, and then non-spatial attribute tables, and of course what I call flat files. You guys have probably heard me say that several times now throughout the course. Flat files, just tabular data. And so joins and relates allow us to make some sort of a linkage or an association between two or more tables that are not currently linked, or they're not currently associated. So we may have some useful information in a table that we would like to demonstrate spatially with points, lines, or polygons, and so we could do what's called a join or a relate between the two. So we're going to break it down into joins and relates, a couple of different types of joins, and we'll discuss a couple of those. And we're not going to demo every one of them, but a couple of the ones that we'll need to do will be demonstrated within the joins and relates demo video. So one of the main things to remember when you're doing joins or relates, or when to choose a join versus a relate, or a relate versus a join, is the cardinality. So this concept of cardinality really talks about that relationship between the tables. Do you have a one-to-one relationship, meaning that you have one record in one table that corresponds only to one record in another table, versus a many-to-one relationship where you have many records in one table that are associated with one record in another table? The flip side of that, and this is not, these are not interchangeable, many to one and one to many. They're actually two different relationships. One to many is going to be where you have one record in one table, maybe in your shapefile, that's associated with many records in another table. And then of course many to many, where you have multiple tables, more than two tables, that have some sort of relationship between them. So I've got several examples here. Many of these will probably make a little bit more sense when you look at the demo. But for now, I did want to sort of address them. Each state, for example, having only one population value. So if we had a state shapefile that was just the states, but we had its total population value for each state contained within a separate table, that's obviously going to be a one-to-one example, because each state is only going to have one population value for a given year, for example. Our many-to-one example here is many parcels may have the same land use code. So you could have multiple parcels, property parcels, that have a land use code of residential, or have some sort of forested or agricultural land use. And so this is an example where we would maybe have a lookup table that tells us what the different codes would mean. So I keep using 11s, 12s, 13s, 20s, and 40s and 50s in my land use example. We'll see a slightly different one in the lecture and in the demo. A one-to-many relationship, you could have a parcel that has multiple tenants. A really good example of that, of course, obviously, is a renting situation. There may be one owner that owns the property, but there are going to be multiple tenants that live within that property. And of course, the multiple parcels having multiple owners. So again, where we have multiple tables, more than two tables, that have some sort of a relationship between them. So understanding this relationship, what we call cardinality, is going to be really important. So as we go through the lectures, we go through the demo, we'll understand, or we'll work towards understanding, which ones of these relationships is key for choosing to do a join or a relate. So first we're going to talk about joins, and there's two different kinds of joins. One is going to be a relational join, and one is going to be a spatial join. So that spatial join we'll talk about here in just a minute, but we'll talk about the relational join first, because when we're talking about relational joins, we're talking about joining information from disparate tables, versus a spatial join, which will join information from one layer to another. So what I have underscored there, common column, or a common or a unique identifier, is very key when bringing tables together. You have to have some sort of commonality between them so that you can join the attributes together, so you can append columns from one table to another. So a couple of examples. We're all very familiar with zip codes. We're now all starting to get pretty familiar with land use codes. So we'll talk about how these might be used within the context of this joins and relates lecture. But I did mention in the last lecture and in the last demo this idea of a FIPS code, a Federal Information Processing Code. So I've got a link in here that talks about what a FIPS code is, and so that launches this map, and you guys can do this as well within the PDF. And so each state in the union has its own 2-digit identifying code, and then each county within each state has its own 3-digit identifying code. So using Maryland as an example here, I'm just going to come over here and hit it from the pull down, and I'm going to say go. And as I mentioned in the previous demo, Maryland's code is 24, and then each county within Maryland has its own individual 3-digit code. And then of course the 5-digit code is going to be the Maryland code plus the 3-digit codes for each individual county. So putting those two together, we wind up with a 5-digit code that uniquely identifies from any other county in the entire United States each county within a given state, in this case Maryland. So and again, just a coincidence that we have 24 jurisdictions. We have 23 counties in Baltimore City, so that's 24. Maryland happens to be FIPS code number 24, but of course if we were to look at, say, Alabama's FIPS code, its state FIPS code is 01, but clearly Alabama does not have just one county in it. So again, it is just a coincidence that Maryland has a FIPS code of 24. So we'll come back to that and revisit that idea of a unique identifier as we move on throughout this lecture and throughout the demo. So let's look at our first example. Here's what we're looking at in terms of a one-to-one relationship. You'll notice that this table over here on the left-hand side has a shape field, and there are polygons representing the polygons of the different states in the United States. We've only got 3 as a part of our sample, and of course the resource document, which I'll pull up here and show you guys, the Joining and Relating Tables by Jim Detweiler. This is a resource that I've used in my classes for many years, and it's a really great breakdown of joins versus relates. You can see the examples I've gone ahead and put in my lecture so that it accompanies what we're going to be talking about. But again, a lot of what's in the lecture is also sort of verbally explained here in written form. So that's one of those resource documents that you want to keep in your back pocket, keep local, so that you understand how to do a join and relate, a join or a relate in the future. So I'm going to go ahead and minimize that to get it out of the way and come back to our lecture here. And so we have a polygon that represents the state of Alabama, has a FIPS code of 1, Alaska has a FIPS code of 2, Arizona a FIPS code of 4. In this case, we have a separate disparate table that has some information about each one of those states. This particular table is demographic information from the year 2000, so we have total population figures. Again, a one-to-one relationship. Alabama back in 2000 was only going to have that one population figure according to the 2000 census when it was completed. And then the same thing for females. So this is a situation where we could show the population of those 3 different states, or we could normalize our data and say how many females or what percentage of the total population in each of the states females represented. So again, that takes us back to our classification and normalization discussion from the last module. So in this case, if I wanted to join this table to this table, this being the attribute table for the shapefile, I have this common field here, the state FIPS code, the 2-digit code, which would then match up and take this information and join it over to the state shapefile. And that is a situation where we have a one-to-one example, and in this case we would do a join. Another example where we would do a join is what we call a many-to-one relationship. So again, bringing the cardinality into it here, we've got land use, land cover parcels, and each parcel has its own unique identifying parcel ID code, but then it is also given some sort of code over here indicating whether it's residential, commercial, industrial, water, forest, or some sort of agriculture. But to the casual user, maybe that LU code is maybe not very easily determined just by the letters RES or COMM. So we might have a lookup table over here that again does not have any spatial attributes or spatial context. It's just a table that tells us that RES means commercial, RES means residential, COM means commercial, IND means industrial. So to be able to join this table to this table, anywhere where we see an RES in this table would get another column right next to it that's called land use description, where it would tell it that it's verbally spelled out as residential, residential, commercial, and commercial. So that's a situation again where we could do a join where we can attach basically this information from this column to this information in the shapefile because we have this commonality, or what we call this unique identifier between the two. The other type of joins that we talk about are spatial joins, where we append columns from one spatial layer to another based on their overlap or their relationship. Again, their topological relationship. So I have a screenshot here that gives us a little bit of context on how we would do a spatial join. Spatial joins are really good when you're trying to sort of quantify how many features from one layer, say these points, fall within the bounds of another layer. For example, these polygons. So let's just say, for argument's sake, that these polygons represent zip codes in a given area, and each one of those points represents a different customer, an individual customer. Now, remember our discussion earlier about counts and amounts. In the case of this data set for these points, each one of these points is a different count. That's 1, 2, 3, 4. Okay, so we might have several thousand points in here, and that is our count. However, when we were to click on one of those points, we could see that there is an amount. Say these are customers. Maybe these are there's a field that tells us how much each customer spent. Maybe their expenditures at a given store. Maybe I have a certain type of retail store that I'm using as my example here. So one of the things that you can do here with a spatial join is you can aggregate data. Maybe I'm not interested in seeing just this dot map of where the customers are. I'm interested in more of a regional analysis where I can see by zip code, using this polygon right here, how many points fall within this zip code, and also how much of the total expenditures in the expenditures field from each of these points totaled together would be within that zip code. And we would see that with this cluster of points up here, maybe we have a lot of customers that fall within this polygon, and maybe they all spent a lot of money as well. So then we could color code these polygons according to how many customers or according to their expenditures. So again, that takes us back to the idea of how we classify our data. And so those numeric attributes can give us those expenditure amounts so that we total that, and then we can make a choropleth map rather than a dot map showing the distribution of expenditures and the number of customers within a region. So that's a really good example of how we would use a spatial join. The demo is really going to focus more on relational joins, but a spatial join will be one of the ones that you're going to have to do as part of your first project for the course. We move on to relates now. Relates are a little bit different in that we're setting up a temporary linkage between our tables because we have a different type of cardinality relationship, in this case a one-to-many relationship. Here we may have a buildings layer that, obviously indicated by our shape field, have polygons, and so we have building 101, 102, and 103. Over here we have a second table that tells us who are the tenants of each of the different buildings. So in this case we have a one building to many relationship. We can't join these two tables together because we can't force these two records into, sorry about that, let's go back. We can't force these two records into this one record in the shapefile. So what we would have to do is we would set up a temporary relationship between the shapefile and this table so that we could click on this polygon and say show me all the tenants that are associated with it. So that's going to be a one to many relationship. In this case we would do a relate. And very similarly, if we have multiple tables that we have some sort of a relationship between them, in this case we have parcels that are owned by somebody, we have the identification number for each parcel, and then we have another table that tells us for each one of those different parcels who the owners are. You may have multiple owners, so we identify them with an identification number here, an owner ID in this case, but we don't know who they are, so we would actually have a third table here that indicates that owner ID 1 is going to be Donald Trump, owner ID 2 is going to be Bill Gates. We can see that Donald Trump is associated with parcel ID number 1. We can see that Bill Gates is associated with 1 and 2. All right, so he's part of this group of polygons here, whereas Mr. Murdoch is going to be associated only with parcel ID number 112. So again, we're sort of creating a relationship across multiple tables here, and that's what we would call a many-to-many relationship. So you're going to get a chance to practice doing these joins and relates within the context of Chapter 9. So for this module, you'll be working in Chapters 8, 9, and 10, again with the queries in 8 and 10, and then within Chapter 9, you're going to be working on joins and relates. So those are the exercises for this module, and now you can move on into the joins and relates demonstration that illustrates some of the things that we just talked about.